Question. Is feeling inevitable when someone says the words sine and cosine? Fact. In 11 minutes from now, you'll be able to estimate the sine and the cosine of an angle. Stop recording. Stop recording, it's embarrassing. Let's get started. But first of all, a small warning. This video is going to be a bit long, more than 15 minutes. I couldn't find a way to shorten it without breaking its unity. Next videos will be shorter and lighter. What are sine and cosine? Trigonometry could be seen as the art of discovering missing informations in right-angled triangles. It is based on an intuition that someone got thousands of years ago. Let's have it ourselves. Here is an angle. This side has a determined length. So we have an angle and we have a length. How many right-angled triangles can I make using it? I'm going to slide a right angle on it and see what happens. Here it is. So when the perpendicular side reaches the extremity of the determined side, the situation is kind of locked. See? You can't make another right angle triangle with that length and that angle. What does it mean? It means that the whole triangle, with its three angles and its three sides, is determined by just that angle and that side. If it is so, then there must be a way from that angle and that side to find out the rest. And this is the intuition behind trigonometry. Before going any further, we need to agree on something. We need to name the three sides of a right-angled triangle in a way that is the same for everybody in order to avoid misunderstandings. Here are the conventional names. The longest one, which is always not touching the right angle, is the hypotenuse. It's the easiest one. For the two others, it will depend on which angle we're considering, the blue or the orange one. For the blue angle, this side will be the opposite. For the orange one, that side will be the opposite. Do you get it? Logically, the last side has another name, the adjacent side. Of course, it also depends on which angle we consider. Why adjacent? Well, these two houses are adjacent. They touch each other. In a triangle, the adjacent side is the one that touches the angle. The angle and the side are adjacent, they touch each other. So great! Hypotenuse, opposite, adjacent. Let's practice this a bit. Here are triangles. Try to find the adjacent side in each case. Please pause the video now. Here come the answers. Pause again. Because I'm mean, now I'm asking you to find the hypotenuse. Good luck. Check your answers. And because I'm very mean actually, now you have to find the opposite. Here are the answers. I'd love to give you another task, but triangles have only three sides. Don't miss my video about octagons. Okay, now let's go further. After the intuition that in a right-angled triangle, knowing one side and one angle is sufficient to determine the rest, we need an idea. We need to find out how to use that intuition. Here it is. We're going to make tiny right-angled triangles with always a hypotenuse of 1. And for every angle, we're going to measure the two other sides. Here I measure the adjacent, 0.6 something. And now I measure the opposite, 0.3 something. and we will keep these two values associated with that specific angle. Then we will use these tiny triangles to study bigger triangles just by multiplying. Let's take a few examples. If we take a right angle triangle with a 15 degrees angle, the orange side is the opposite, and the pink one is the adjacent. The hypotenuse in blue is 1. On a unit triangle like this, the opposite is called the sine, and the adjacent the cosine. Note that I call it unit triangle. It's not an official denomination. It's my personal thing, because I think it is convenient in order to explain you trigonometry. So we can measure it and say that the sine of 15 degrees is 0.26. As you can see, the opposite is around 4 times smaller than the hypotenuse. So 0.26 makes sense. And the cosine of 15 degrees is 0.97. It's almost as long as the hypotenuse. Sine and cosine could even be seen as a percentage of the hypotenuse. If I rotate the sine to put it next to the hypotenuse, you can see that it represents 26% of the hypotenuse. 26%, 0.26. Now, if I rotate the cosine to put it next to the hypotenuse, you can see that it represents 97% of the hypotenuse. 97%, 0.97. So basically, we can consider that the sine expresses how many percents of the hypotenuse is the opposite, and the cosine expresses how many percents of the hypotenuse is the adjacent. Note that sine and cosine are necessarily smaller than 1, because the hypotenuse is 1 and it's the longest side. Let's do the same with 30 degrees. Sine 30 is 0.5 and cosine 30 is 0.87. 45 degrees, sine and cosine are both 0.71. It's not surprising because that's half a square, so both sides are the same. 60 degrees, well, it's the inverse of the 30 degrees one. Sine is 0.87 and cosine is 0.5. Why? Because in a triangle, the sum of the angles is always 180 degrees. So if one angle in a right angle triangle is 60 degrees, then the other one is necessarily 30 degrees. So the situation in 30 degrees and 60 degrees cases is actually the same, but flipped over. Same thing for 75 degrees, which is a mirror reflection of the 15 degrees. Now, let's imagine that someone has a lot of patience and measures very carefully the sine and the cosine for every angle and makes a table from that. Here is what it would look like. For every angle, you have a sine and a cosine. Let's take 11 degrees. Here you have the sine and there the cosine. Sine and cosine are just the length of the two small sides when the hypotenuse is 1. This table is in your calculator or even in your phone. You enter the angle, it gives you the sine and the cosine. And you can, of course, enter the sine and the cosine and get the angle. It works both ways. Usually, it takes using the Shift key to access the reverse function. I'm sure you will find out the way to do it on your own calculator. Now, I'd like to make this a little bit more continuous. I mean not 15 degrees, then 30 degrees, just continuous. Let's use a graph for that. Here, you can see that I drew a quarter of a circle on a graph. Let me guide you. The radius is 1. The graph is basically zoomed in compared with what you usually use. Is that right? Look at the segment AD between A, 0, 0 and D on the circle. It is the hypotenuse of a right-angled triangle. You can read the coordinates of D by projecting it to the horizontal axis and to the vertical axis. So basically, the x coordinate of D is the cosine of the angle. And the y coordinate of D is the sine. Look what happens when I move D along the circle, which keeps the hypotenuse at a length of 1. This is important. The hypotenuse, for being the radius, doesn't change its length. So our right angle triangle is always a unit triangle. Pay attention to the cosine first. It varies from 1 to 0. Let's do it again, but this time focus on the sine, I mean here. It varies from 0 to 1. So, putting our right angle triangle on a graph allows us to read the cosine and the sine on the axis. Let's have a little practice. Here you can see two angles. I'd like you to estimate their sine and cosine. Please pause the video now and resume it when you're done. Here are the answers. I hope you got them right. If not, you're sentenced to watch the video from the start again. I'm not joking. Okay, so you're back here. That's great. Now you understand what are sine and cosine, but you may still wonder, what's the use of that? Here it comes. A big right angle triangle is nothing else than a small one that you have enlarged. Let's take the easy example of a triangle with a hypotenuse of 3. You can put 1, 2, 3 unit triangles along its hypotenuse. What does it tell us for the opposite side? Let's project the sine to the opposite side. It fits 3 times. Now let's project the cosine to the adjacent side. It also fits 3 times. So our triangle measures 3 sine A and 3 cosine A. Guess what? If the hypotenuse was, let's say, 4.7, well, we would have 4.7 sine A and 4.7 cosine A. That's simple. Let's practice this a bit. First, an easy one. Here is a right angle triangle. Pause the video and try to find AB and BC. You will need a calculator. Are you done? Let's see that together. On a unit triangle, the hypotenuse is 1, but here the hypotenuse is 3.8. It means that this triangle is 3.8 times bigger. Everything is 3.8 times bigger. So AB, the opposite side, is 3.8 times sine 40. Using a calculator, you must have found 2.44. BC, the adjacent side, is 3.8 times cosine 40. So here it makes 2.91. Ready for a harder one? Here it comes. You have to find AC, the hypotenuse. Pause the video and we'll meet after. Are you done? Okay, how much bigger is this triangle compared with a unit triangle? On a unit triangle, the hypotenuse is 1. Here the hypotenuse is AC. So the triangle is AC times bigger than a unit triangle. I know we don't know AC, but we can use it as an unknown number in an equation. So we will just write that AB, the opposite, is AC times sine 28. AB equals AC times sine 28. We know AB and we can find sine 28 with a calculator. So we can find AC because it's the only unknown of the equation. Let's solve it. I want AC alone, so I'm going to get rid of the sine 28 by dividing both sides by sine 28. Here it goes. Now I simplify the fraction by cancelling the 2 sine 28. And get this, now I replace AB and sine 28 with their values. And that makes 16 centimeters. Come on, a last one, here it goes. This time I'm asking you to find the angle. Good luck. Pause. Let's do it together. The hypotenuse is 9, right? This triangle is 9 times bigger than the unit triangle. It means that 7.2, the adjacent side, represents 9 times the cosine of the blue angle. Let's write it like this. 7.2 equals 9 times cosine. If I want the cosine of the blue angle, I must get rid of the 9. So I'm going to divide by 9 on both sides. Now I simplify by cancelling the 2 9s, and we get this. But we're not done. It's not the angle, it's the cosine of the angle. We need to use the calculator to get back to the angle itself. So we use the reverse function. On most calculators, it's with the shift key. Let's do that. So you type this and get 36.87 degrees. Here is our angle. We're done for today. Watch it again tomorrow, do the training again before you skip to the next video. It will help you remember. 3 times wouldn't be a bad idea either. Please like, share, subscribe, activate notifications, and some homework. Tell your parents that your new teacher needs to earn his living, just like anybody else. They can contribute a tiny amount on Patreon to help me create more and more videos to help you. The link is in the description below. Take care, amigos. I'm happy that you're giving math a second chance. You're going to succeed. No worries, so keep going.